Before we begin section 5.4 day 2, I just want to point a couple of things out. First of all, there is a little bit of a misprint in your PDF notes. At the top, it says section 5.2 day 2, but it's actually section 5.4. Sorry about that. Today, there's two things that are in the notes. I'm not going to look at number 2. If you glance your eyes down at number 2, this is the good old Venn diagram that we've been starting since as early as chapter 3, and it's nothing new. It's exactly the same as the volleyball basketball question that we had done earlier in this chapter. You've been doing this question for quite a while. The only difference is we went to percents for probabilities. The total is just 100. I'm going to leave that for you guys to take a look at because, again, nothing is new there. So then the only question we really need to take a look at is rolling die. And I know you're thinking, well, what is this grid and why do we have to look at a rolling a die question? This is easy. If I just take a standard 6-sided die, it's a 1. What was the probability of it being a 1? Well, 1 out of 6. But let's say you have 2 die and you have 2 different die. They are 2 different colors. If we said, well, what is the probability of rolling 2 ones, which is called snake eyes in Las Vegas? When I roll it, the probability of that happening, we have to figure that out. And you might be wondering, well, I don't know. It looks like there's only maybe one way to get snake eyes, 2 ones, but I don't even know the total number of things. It could be a 1 and a 1. It could be a 1 and a 2. It could be a 2 and a 4. We just don't know. This grid takes a little bit of time to make up, but then it just saves the day and it's so easy to use. And so here's what I want you guys to take a look at. Let's say that the red die, it can be any of the numbers 1 through 6. The yellow die can be any of the numbers 1 through 6. Suddenly, we have exactly what we need. If we were going to say, well, what are all the different possibilities? Well, the red die could be a 1 and the yellow die could be a 1, a 2, a 3, a 4, a 5, or a 6. And then you see where the pattern goes, and a 6x6 grid, there's 36 different options for rolling the die. Now, when you do this grid, then the grid becomes such a valuable tool. What if we said, okay, we're going to roll these die, and right now I have 2 6s, that is called doubles. What is the probability of this event happening? Okay, so I'll just go probability E. Now here's what we know. Probability is always the favorable outcomes, also known as what you want over the total. Well, how many different things could happen when you roll 2 die? 36. It's always going to be 36. Now, what are the doubles? This is kind of neat. I'm going to have to make a mess and then wash my hands. The doubles. They are the 1 and the 1, the 2 and the 2, the 3 and the 3, all the way up. Those are all the doubles. It can be 6 and 6, 5 and 5. You get the idea. Well, how many doubles are there if we count? There are 6. And then we can reduce this to 1 over 6 if we want. But again, I don't really care about reducing. So this chart really would show it. If you were doing some kind of bet with somebody, what is the probability that if I roll this, I get doubles? Well, I didn't because I only had a 6 in 36 chance of getting doubles. Now we move to the next guy, and I'll just have to take a moment to do the erasing. My apologies here. The grid is really useful, but it gets kind of messy. What if we said, what is the probability of rolling the die and getting a sum of 7? So what is the probability of this event happening? The denominator is easy. The total number of things that can happen would be a 36. I'll just bring these dots back in a little bit better. Now, for this guy, watch where the circles come. If we roll these die and we want to get a sum of 7, it could be a 4 and a 3. So it could be a 4 on one die and a 3 on the other. So let's say, again, we put the red die here and this one here. It could be a 5 and a 2. It could be a 6 and a 1. Now, just what I want you to see is this spot, the 6 and the 1. That would be yellow die 6, red die 1. But we could switch it. If I circle this dot, that is different. That's a different scenario. That's red 6 and yellow 1. And so then when you see these circles, we would see how many different ways you could get a sum of 7. Now, you guys, this is not always the case. Anytime there's 2 die, you don't suddenly slap down. The probability is 6 out of 36, 1 out of 6, as you will see with the next problem. Let's say we were going to roll the die, and we wanted to know what is the probability of getting a sum of 6 or a sum of 3. And so you imagine some kind of gambling, you're betting somebody, what is the probability of this scenario happening? Here is how we would begin this. And I'm sorry I have to write so small. First of all, we'd have to say, what is the probability of getting a sum of 6? Well, the sum of 6 would be as follows. It could be a 1 and a 5, a 2 and a 4, 3, 3, 4, 2, which is different, and then a 5 and a 1. There'd be 1, 2, 3, 4, 5. There'd be 5 out of 36 chances of this happening. Now, the big question is, what does the word or mean? It's an add. And means multiply. Well, how do you get sums of 3? That would be a 1 and a 2 and a 1, and that's it. So there would be 2 out of 36 chances. And then you see in the PDF notes, 7 out of 36 would be your total probability. Now, here is our final one. What would be the probability of the event getting 6s or getting doubles? Now, we already have the 6s done. That is 5 out of 36. Let me just take a moment and get rid of these guys. So then the big question is, where are doubles? Well, we know that already from the first one. It's a 6. Now you might be thinking then, well, do we just put down a 6 out of 36 right here and then we're done, it's 11? No. If we take a look at all of our doubles, here's where our big one comes in. We can't double count, okay? We don't actually say it's 5 plus 6. This one counts twice. And then what you see in the notes is we take away that one time, that intersection between the two. Sorry, that's so messy, but this is a 1 out of 36. And then we see our total probability of being 10 over 36. So when you're rolling 2 die, the key is draw the grid. If the grid is worth the minute that it takes to put up, because then whatever it asks you, you will clearly see how many things out of the total it is.